We're going to first look at conservation of energy just from a qualitative perspective. So conservation of energy means that the total energy of the system remains unchanged, but you may change the type of energy. So total energy is equal to all of the energies that are present. We're just going to be looking at three different types of energy: potential energy, kinetic energy, and work to overcome friction. So remember, all of the units here are in joules. Just a refresher, potential energy is the stored energy, and we're talking about it in terms of height. So as I work to bring something to a higher height, it will have higher potential energy. At a lower height, it will have a lower potential energy. Kinetic energy is the energy that is the result of motion, a mass in motion. So that's going to be equal to 1/2 mv squared, where the velocity has an exponential effect on the kinetic energy. And the work to overcome friction is the amount of force that I have to apply over a distance to overcome the friction that is there between the two objects that are moving. So sometimes an object can have only potential energy. That will happen when it's not moving, right? Because kinetic energy requires V to be greater than 0 or less than 0. It has to not be 0. And work to overcome friction has to require movement. Sometimes an object only has kinetic energy, and that's when it would be at the lowest height and when no friction was occurring. So at the top of a hill, before a ball falls, my total energy is only going to be equal to my potential energy because I'm not moving, right? So because there is no motion, I'm not going to have kinetic energy or work loss due to friction. So the PE at the top is going to be equal to my total energy. Well, by the law of conservation of energy, whatever that number of my TE that I calculate will be the total energy at the bottom of the hill as well. Now, if I don't have any friction in this case, and I'm at the bottom of the hill, then both my work loss due to friction and potential energy are equal to 0. So at the bottom of the hill, in this case, I only have kinetic energy. Well, if my total energies remain the same, and at the top, my total energy is equal to potential energy, and at the bottom, my total energy is equal to kinetic energy, by the transitive property of mathematics, my potential energy at the top of the hill is going to be equal to the kinetic energy at the bottom of the hill. So this will enable me to figure out things like how fast my ball should be going at the bottom of the hill. So what if there's friction? So if there's friction, the total energy at the top still remains the same because I'm not moving, right? So I have no kinetic energy, I have no work loss due to friction, nothing's moving. So my total energy at the top will always be equal to my potential energy. Total energy stays the same. At the bottom, my potential energy is going to be equal to 0, but because I had to do some work to overcome friction, my total energy at the bottom will be equal to my kinetic energy at the bottom plus my work loss due to friction. The more friction I have, because my total energy doesn't stay the same, and that's determined by how high my object was to begin with, the more work loss I have to do to friction, the lower my kinetic energy will be because I'm taking away from that, right? So this is my total up here. It doesn't change. If this number goes up, then this kinetic energy, what I have left over, is going to go down. So if my kinetic energy goes down, then that means really my velocity is going to be smaller, and that makes sense, right? So if you're sliding down a water slide versus a grassy hill, your velocity at the bottom of the grassy hill is going to be a lot less than your velocity down a water slide of the same height. One of the reasons why water slides are so fun to go down is that the friction force is a lot less, and so the work loss due to friction is going to be less. So more of your potential energy gets converted into kinetic energy. You end up having a much higher velocity at the bottom than you would if you had a grassy hill.